What's up, everybody? Hope you had a great day.
Is that you, yeah?
What's up, everybody? Welcome to one of our final live sessions. This is going to be our second last one. So make sure that you share this live, double tap the screen. We have to push through. I know you just finished your math paper about 3.5 hours ago, 3 hours ago, 4 hours ago. But yeah, we're going to start this session in the next 10 minutes, 5 to 10 minutes. Make sure that you double tap the screen and share this live to as many people as possible. So double tap the screen in this way, it will pop up on the For You page. Maybe there's someone that needs a little bit guidance with paper 2. They have questions, they can also ask the questions here. If there's anything in connection with the paper that we're going to do today. So basically we're just going to focus on 3 questions. Question 3, 4 and 5 of 2018 November. It's the final paper. It is analytical geometry and trigonometry. So I'm just working according to the poll I did a few times already. I had a list, I had a live session, I had in my DMs where I asked, okay, what are we going to do in our next session? So that's what we're going to do tomorrow. We're going to continue with this session. I'm not sure what time, depending on, as you guys know, we work according to Eskom's schedule. So make sure that you double tap the screen, and thank you for following Nishan. We're gonna start. Oops. We're gonna start. Let's make it 15:45. So in the next 7 minutes, we're gonna start. Okay. So make sure that you share this live. Double tap the screen. In the next 7 minutes, tell me how was paper one for those who wrote paper one. How was paper one before we start off? I'm writing math paper 2 on Monday. Yes, I probably need this help right now. Okay, Nishan, cool. Yeah, so make sure for those who don't know, we do these live sessions up until Saturday. And then after that, we're going to do different grades. So if you're in a different grade, share this live, okay? If you're done with school and you're a parent, just this popped up onto your For You page. Share, okay. Okay, so let's see. Hi, baby girl. Hi, Nishan say I couldn't even finish the paper. Oh, flames. Realty say flames. What time? Baby girl asks what time. It really depends on. You see, I can't. The best thing for you to do is it's gonna be in the morning. Okay, so it's. Let me say it's gonna be before 1 o'clock. Okay, because I have other stuff to do after 1 o'clock. But I'm going to try, I'm not making any promise, I'm going to try and push in something during the day, because it will be our final session tomorrow, okay? Okay, Boo say, Nishan, me too, I honestly feel like crying. Guys, don't be so negative, positive vibes. I know it sounds a bit cheesy. Yeah, so in the next 5 minutes, we're going to start 15:45, so make sure that you share this live. Double tap the screen in this way, it will pop up on the For You page so that more grade 12 students can see this. But in the meantime, for the next 5 minutes, let me know how was your paper one, okay? And a great percentage, more than 80%. I did a poll, posted a video today. It's an old video, but I reposted it with a poll on there, and 80% of you, probably grade 12 said it didn't, they rather say nothing. The others, 12% or 20% say okay, it was okay. Let's see, guys, Tiamo also want to know, how did you write? Tiamo. It was fine. Leshlo Nolo said it was fine. Okay, that's the first positive comment. You know, sometimes you think it's that bad, but not such a good paper. Dazzy Lee say not such a good paper. Motivational mix say people complaining about question 9. Tiamo say, wait, baby girl is saying, but question 9 and 2. 9 and 2, question 2. Hey. Question 2 as well as 9. Oh, question 2. I couldn't finish question 2. Nishan said question 2, 8, 9, and 10. Wow. Isn't that the whole paper? So for those who have just joined us, make sure that you double tap the screen, share this live, because in the next 3 minutes, we're going to work through 3 questions. It's going to be based on analytical geometry, and it's going to be based on trigonometry, because in the past few weeks, that's where most of the concerns are, so we're going to work through that. And then also, I'm not making any promises for a second session tomorrow, but the first one will be before 1 o'clock. Yeah, so make sure that you follow, okay, so that you can be notified when this stuff is happening. When will you do Euclidean? We're gonna try and do some. Didn't plan for today because we're just gonna do analytical and trigonometry. So we're planning to do that tomorrow. Some comments. Yeah, so thank you very much for sharing. Yeah, guys, share the live and double tap the screen. In this way, more this will pop up on the For You page or the lives. Do you do grade 11 pure maths? Mfefe asked, do you do grade 11 pure maths? Yes, but not today, not tomorrow, from Monday onwards. But I will make the announcement. Some Dishani saying, by the way, I'm rewriting my subject again this year, including maths, physics. Do you also teach physics? Unfortunately, no physics. But I know there is someone. You know what's popping up a lot recently? Not, I will say on my For You page, because I'm sharing a lot of educational content, basic educational content, most of it. Is there is someone, I can't remember a name, that's doing physics, but I'm not sure. Yeah, you can just, I totally forgot her name. But it's a South African lady, it's a South African white lady, so you can just check her. It's a white teacher. Are you going to cover all paper 2? No, it's going to be impossible. So Josh is asking, you're going to cover all math paper 2 topics? No. It's going to be challenging, it's going to be impossible, because my method or the process that I have here, it's 3 questions, but we might not be able to finish all the questions, because I will read a question and then you do it. I will give you a 1 minute or few seconds head start, and then we do it together. Somebody asked, when is Euclidean tomorrow? We're going to try it for tomorrow. Just need to get at least exam formats this time, please. What topics are you going to do? Realties, we're doing analytical and trigonometry. Okay, so let me just connect my mic. I think it's better with the mic. Yeah, so guys, let me know if you can hear me, because sometimes this mic doesn't want to work properly. There's going to be a lot of noise in the background. It is Friday, it's weekend, so you're going to hear a lot of cars. Okay, so let me just get my pen. Let's start. We're going to do question. It's going to be question 3. Hopefully you guys can see that. We put this away. Can hear you. Okay, Dishan is, give me a thumbs up if you can hear me properly. Dishan can hear me. Okay, so this, by the way, important. It's important for you to take out a pen. This is not movie. It's a bit, I call it a bit of entertainment, because while I give you that few seconds of you working through the question with me, I'm going to play a little bit of music in the background. So, but important thing for you is to take out your book and a pen and a calculator. We're not going to use a lot, okay? Okay, so let's look at the first question. The first question, okay, here we go. Let me just see if I can zoom in a little bit more. Turn around the paper, please. What do you mean turn around the paper? This is how you're going to see it. Okay, you need to keep your cell phone landscape view. Okay, because this is the best view that you're going to get. Because my cell phone is in landscape, so yours horizontal, and mine, that's going to be the best. If I'm going to do it vertically, you won't be able to see a lot of stuff. Okay, so let's look at the first question here. They say in the diagram, K, -1 and 2, so there is that point, and in is 1 and -1, these in 1 and -1, that coordinate. They say those 2 coordinates are vertices on the triangle KLN, okay, KLN, such that L angle KN is 78.69. So there they show that to us. And there's further on, say KL intersects the x-axis at P. So there we go. So here the point P. Let me just make a dot there so that you can also see that point there. Then further on they say KL is produced. So they just extend it a little bit further. Then they say the inclination of KN is theta. So angle of inclination, there we go, it is theta. And then they further on they say the coordinates of M are -3 and 5. So here are the coordinates of M. So it's -3 and -5. Okay, so let's look at the first question, which is only like 2 marks, and they ask us to calculate the gradient of Kn. So I want you to calculate the gradient of Kn, and then we're going to move. I'm going to do it with you. I'm going to give, this is like 2 marks worth, but you don't have to spend 2 marks, 2 minutes or 3 minutes. But I'm going to give you that few seconds, 1 minute head start. Okay. So there we go. For those who have just joined us, make sure that you double tap the screen and also share this live. In this way, more grade 12 students will see this live. This is going to be our final live session today and tomorrow. And also share to those who actually need a little bit of guidance for paper 2. And if you're not in grade 12, you're in a different grade, or you're done with school, finished with school, please share this live as well. And even for the next few seconds, just spend 5 seconds double tapping the screen. If you have the answer, you're more than welcome to comment your answer, or you can just give me a thumbs up. That's just the indication for me that I should move on to the next question. Okay, anybody got the answer there for me? If you have the answer. Okay, so let's do this one together. Okay, so 3.1.11. Okay, the gradient, this is the formula that you will get this formula. Obviously, you need to know what the gradient formula is. You will get it on your formula sheet, and you basically just say that the gradient, we are looking for the gradient of Kn. So the gradient of Kn is going, that's a n. It's y2 minus y1 over x2 minus x1. So your x2 and your y2 can be anything. So I'm going to say this one. So this one minus that one. So it's going to be 2 minus 1 over, because this was my y2, so this must be my x2. So it's going to be this one minus this one. So it's -1 minus 1. So it's -1 minus 1. This is going to be 3 over 2. Okay, -3 over 2, and this is your final answer. Okay, let me see. Okay, somebody asked Lesego asked what's the device? Sorry to be off to, I'm not sure what you mean by for the device. Somebody asked, can I ask what are the properties of a rhombus? Well, you need to, Mr. Okay, now that you want to know, so this is the thing, cool thing about internet. So I can't show you that whole topic. It's quite a good question, but it's also cool that you asked that, because I was just about to say, with these type of questions, somebody asked me this a few months ago, and I remember making a video I responded on that question. And an important thing when it comes to analytical geometry, you need to know basically all of your 2D figures, rhombus, parallelogram, kite, all of those things, because you're going to need it here. Okay, and somewhere in this question, further on in this question, you're going to see you will need to know what's the properties of a parallelogram. Okay. Okay, let's say I'm using Galaxy Samsung S7 Edge. Edge S6 or S7 Edge. Okay, so let's go on to the next question. 3.1.2. And the next one asks us the size of theta, the angle, the inclination of kn. Okay, so we're looking for this value here, theta, and it's worth 2 marks. So I'm going to give you another few seconds head start so that you can do that one. Okay, so we're looking for the size of the value of theta, the inclination of kn. For those who have just joined us, make sure that you double tap the screen and also share this live. In this way, more grade 12 students will see this. If you're done with school, please double tap the screen, share this live. It will help a lot. Okay. Thank you for the roses, Lesejo. If you have the answer, you can comment it as well. Okay, so 3.1.2, they ask us to calculate the size of theta. Okay, we need that angle, the angle of inclination. So there is a formula which is that you're going to use, small little one, that's a tan of theta equal to the gradient. So we need a gradient of kn. Do we have the gradient of kn? Yes, we calculated in the first question. So now the other warning that I want to give you here is, obviously you've noticed that if you don't get this answer, the previous answer is always important. If you get this wrong, everything after this will probably be wrong. Okay, there's a chance that everything after this will be wrong. So that's why make sure that you get this, the first question. But the first question is always, I will say, easy. Okay, so 3.1.2, they ask us to calculate the size of theta, which is this angle here. So we need the gradient of that one. We calculated the gradient, which was -3/2. So let's first write down that formula. So tan of theta equal to the gradient of kn. What is the gradient of kn? It is -3/2. So this is where you're going to need your calculator. We're going to type in your calculator tan of theta, shift tan of this, but you exclude the negative symbol. So this is grade 10 stuff. I made a few videos, I think, based on this one in the grade 10 playlist. You will find this on my TikTok playlist. Okay, so your theta will then be 180 degrees minus 56.31. I already calculated this. This is because I typed this in a calculator. You'll get that your theta value is equal to 123.69 degrees, and this here is your final answer. Let me see how many of you guys got this. Which paper is this? This is 2018 November NSC or DBE. Which question we're doing? We are busy with question 3. Let's see. Analytical geometry paper 2. Yes. Are you on YouTube as well? Yes. I got it. Keibu, congratulations. You got it. Let me give you some love there. Okay, give you some love. Okay, let's move on to the next question, where they ask us to show that the gradient of KL is equal to 1. So we need to prove now that this is equal to 1 here. I'm going to give you a few seconds head start as usual. So we're busy with 3.2 now. We need to show that KL is equal to 1. Remember, we're not going to be here the whole day. We have about 47 minutes still left, or 43 minutes. Wait, 48 minutes. We're working through 3 questions. And for those who have just joined us, make sure that you take out a pen and paper, and also if you're in a different grade, make sure that you share this live. Okay, double tap the screen. In this way, more grade 12 students will see this. Guys, we're going to have an ad break. Somebody gave me an idea the other day. Okay, somebody say, why are you subtracting from 180? Please explain that. Okay, so this is from your grade 10 stuff. Remember, tan of theta equal to -3/2. Okay, and then you're not supposed to type in your calculator shift tan of this. You need to type in shift. Let me just show you. Hopefully you can see my calculator. Shift tan of 3/2. Let me just close that. Okay, so if you're not supposed to type that in, but in that section where, in this section, in the grade 10 section, they say, you need to ask yourself now, where is tan negative? Tan is negative in the second quadrant. So only sign is positive there, that's the whole thing. So that's why we have that 180 minus. If it was positive, then you can jump straight to that. Okay, so this comes this year, this piece of this section here is grade 10 stuff. Okay, so go check it out. And then obviously 180 minus this value. Okay, cool. Okay, we were busy with question 3.2, guys. We want to calculate the gradient of KL. Wait, we need to show that the gradient of KL is equal to 1. When do we subtract 180? When do we leave it like that? Okay, I think, okay, so this section here is in the grade 10 trigonometry section. You need to ask yourself, where's tan negative? Tan is negative, second quadrant. So that's why we do that 180 minus. So if it was positive, then you don't do the 180 minus. So we're busy with question 3.2. Show that the gradient of KL is equal to 1. If you got the answer, double tap the screen or just give me a thumbs up. Or you can even type in here. Some of you guys send text like what you did. That will also help. That will also be cool. Okay, so let's get to this one. Let me just zoom. I think I zoomed in too much now. Let me do that. Okay, there we go. Okay, question 3.2. This is where they ask us to show that KL is equal to 1. So we need to show that the gradient of, the gradient of this line is equal to 1. Now, previously we calculated this angle, but remember, to get the gradient of this line, right, you need, well, to get what the question asks us to show that the gradient is equal to 1. So now, to prove that the gradient is equal to 1, or to get this gradient, we need this angle here, also the angle of inclination. Now, do we have this angle? No, we need to calculate this angle here. So to get that angle, there's a few ways you can get this angle here. But I think the easiest one will be where you need to know one of your theorems that you've learned earlier in your math life, if I may put it that way, we'd say this angle is equal to the sum of the interior angles. So that's exterior angle is equal to the sum of the interior angle. So that's what I'm going to use here. Other way will be where you get this angle. Okay, so you have this one here. Then you subtract 180 from this one to get this one. And then you need to subtract 180 again to get this one, because angles in a triangle adds up to 180. And then you're going to use this here to calculate your gradient. Okay, so let's write down mathematically what I just said. But I'm not going to use the latter one. I'm going to use my early knowledge of where I've learned earlier that this angle is equal to the sum of these two angles here. So let's do that. So it's going to be, let's call that angle the angle of inclination. Okay, so that's what I'm going to do. Or you can say kpx, or angle of inclination. It's really up to you. So I'm going to say inclination of KL, let me see, angle inclination KL, let me write it like that, equal to, earlier on I got this value here as 123.69. So as you can see, you actually need your previous answer to be correct to answer the following question. So it's going to be 123.69 minus this one here, okay, 78.69. So that's going to give us an angle of 45 degrees. And now we're not looking for the angle of inclination, we are looking for the gradient of KL. So now we know that tan of my angle of inclination, which is 45 degrees in this case, is equal to 1, and that's your final answer. I've proved that the gradient of this is equal to 1. Hopefully that makes sense. Let me know, I will explain it again. And if you did it another way, like I said, to find your angle of inclination, it's really up to you. You're supposed to get the same answer. Oh, somebody asked, what paper is this? This is paper 2, Math 2018 November. Okay, so let's move on to the next question. If you have any questions based on this one, please let me know based on this question. Show that the gradient of KL equal to 1. Okay. Exterior angles of a triangle, yes. Exterior angle. Okay, so let's move on to this one. 3.3 asks us to determine the equation of the straight line of KL, so the straight line of KL in the form y equals to mx plus c. Okay, so I'm going to give you a few seconds. This one is worth 2 marks, so I'm going to give you a few seconds to do that one. Let's see what's happening here. For those who have just joined us, make sure that you double tap the screen, share the live. This is one of our final live paper 2 math sessions. I know you guys have just finished, yes, this is going to be the best, I won't say the best session. Okay, so anybody have, if you have the answer, you can double tap the screen or you can comment the answer. Okay, so let's get to this question where they ask us, what is the equation of the straight line here? So there's 2 things that you basically need to get, in your case, to get the equation of a straight line. It is, one, you need a coordinate or a point on that line, and you need a gradient. So the first thing, let's answer that first question. Do we have a coordinate or point on that line? Yes. We have -1 and 2. Do we have a gradient on this line, of this line? Yes, we calculated a gradient and we well, we prove in question 3.2 that it's 1. So let's use this piece of information or this answer here and that piece of information and substitute it into one of the equations to get your line. Okay, so let's quickly do that here. I think I will have enough space here. Okay, so it's going to be 3.3. We know that that special formula is y minus y1 equal to m x minus x1. Okay, so we don't have this, or well, that's just part of the equation, so we leave it as it is. Y1 is going to be my y value of the k coordinate, which is 2, so let's substitute that in there. The gradient is the gradient of this line, which we calculated in the previous question, which we saw it was 1, and obviously this is part of your equation, and in the x-intercept is -1, so let's substitute that in there. That will be negative, which is this negative, and the x-intercept, or the x coordinate. So if we simplify this a little bit, we will see that your y is equal to x plus 3, and this is your final answer. Okay, if you guys understand that, let me know. Somebody got negative x. Okay, you made an error somewhere. You say negative 1x. Because remember, we calculated our gradient previously as 1. So you're just supposed to substitute 1 in there. Okay, I think I got that answer. Okay, so for those who have just joined us, we are doing, this is our second final revision for paper 2. We are working through 2018 November, paper 2 DBE question paper. Okay, so if you've just joined us, take out a pen and paper if you want to work. This is edutainment, so we learn a little bit, explain it, you won't hear any music, and then when it's your time to do, I will play a little bit of music. So let's move on to question 3.4. Okay, into question 3.4. Okay, we still have 35 minutes left, so let's see how far we can get with the next question and even with this one. So here they're telling us, or this asks us to calculate the length of Kn. Quite easy. They're asking to calculate the length of Kn. So this one is worth 2 marks. I'm going to give you a few seconds head start and then we can do it together. If you have the value of Kn, you can comment it, you can double tap the screen, or you can just give a thumbs up if you have it. We're busy with question 3.4. Okay. If anybody got the answer, let me know. Double tap the screen and this way I'll know. Okay, you with me? If you're a little bit shy to answer your question, just give a thumbs up. Okay, let's get to the answer of this one, which is to calculate the length of Kn. Kn, here we want this length here. So basically length, distance is the same thing. So we are actually trying to calculate or find that we're going to calculate the length by using the distance formula, which you will also get on your formula sheet. So let's substitute these values into our distance formula. Just remember, your Kn and your x2 and your y2 can be anything. Okay, so this can be your x2 and this your y2, and then this will be your x1 and your y1. Or you can, other way, it's really up to you how you want to which variables you're going to use and substitute it into your formula. Let's write that mathematical down. So we're going to calculate the length of Kn, which is equal to open bracket 1 plus 1 close the bracket 2 plus -1 -2 close the bracket. Okay, if you type this in your calculator or solve it by head, you will see it is square root of 13. Or if you want to leave your answer in 2 decimal places, you'll get 3.61, and this is your final answer. How many got 3.61? How many of you got square root 13? Quite easy. 2 giveaway marks. Okay, so at least if you got everything wrong, you're supposed to get this one wrong, right? Excuse me. At least this one, and at least this one. Remember, if you get this wrong, more or less everything after that will be wrong. Okay, Polisa is asking, which year is this paper from? 2018. This is 2018. 2018 November DBE paper 2. Okay, so let's we calculated the length of Kn. Now we're gonna answer question 3.5. Let's do that. 3.5, and here they ask us, it is further given that Kn, so this length here, Kn is equal to Lm. So this distance and this distance here is the same. So this is given. Okay, now they ask us to calculate the possible coordinates of L. So we're looking for the coordinates of that one, given that this length Kn is equal to Lm. Okay, so this one is worth like 5 marks. So I'm going to give you, let's make it 2 minutes and a few seconds head start, and then we can do it together. Okay, if you have any questions, don't hesitate to ask. Somebody's case say this question is really interesting. Yes. Thank you for the follow. Pleasure, Polisa. For those who have just joined us, make sure that you double tap the screen and share this live. In this way, more students will, grade 12 students will see this. We're going to still be here for the next 30 minutes, okay? Because the session is going to be an hour. It's going to be an hour. If you have the answer, you can give me a thumbs up, or you can just double tap the screen. And for those who have just joined us, we are doing paper 2 revision. This is our second final session that we are revising question paper 2, math paper 2. I hope the paper 1 went well. The comments are not looking that good that I've got so far for the day. Everybody's talking about question 2 and question 9. And share this live and follow, because I'm definitely going to do a math live session tomorrow. I assume most of you guys will spend the weekend at home and do revision, unless there's something important that you need to do. Yeah, but I'll try my best to upload if TikTok upload it onto my platform, yeah, I will download it and upload it onto my YouTube. But sometimes they don't do. Question 2 was difficult, Casey. I couldn't find R. Okay, so how many of you guys managed to start off with this question here, question 3.5.1? If you got it, give me a thumbs up. Okay, so this one is quite of a big question, because here we're going to use a lot of things. We're going to use some of our paper 1 knowledge. Welcome to paper 1 as well. And obviously your analytical knowledge. So here they ask us, well, let's first see what was given. Here they say it is given that Kn is equal to Lm. So let me just draw that line so that you can also see Guys, I don't know what's happening, but my battery power is on 2% and this thing has been charging like the whole time. So you must forgive me if this session finish off early. Somebody asked, Maureen asked, is P the midpoint of KL? Where's P? No, they didn't say that. Okay, but what they do say in this question is Kn, this length here, well, Kn is equal to Lm. Okay, now they want us to calculate the possible values of L. So L is that coordinate. So let's do that one. Okay, remember that this length is equal to, they say this length is equal to that length. Okay, so we can actually write that mathematical down. But what we're going to do is, because we don't have Lm, let's call this here x and y. Okay, it's obvious, x and y. Okay, we don't have that. So remember, they say here it is given that Kn is equal to Lm. So the length of Kn, do we have the length of Kn? Yes, we got that as square root 13 Kn there. But the other thing is, we don't have the length of Lm. But what we're going to do is we're going to substitute these values into our distance formula. Okay, and say this one, which is there, is equal to this one. So I'm going to write that mathematical down. So it's going to be x plus 3 squared plus y plus y plus 5 squared is equal to 13. Okay, remember, everything was under the square root. You don't have to include that step, because here we are trying to calculate the values of x and y. Okay, so that's why I don't want to put that in the extra step. But if you want to, you're more than welcome to do that. But this is the distance of Lm, and this was the distance we calculated in the previous question of Kn. So they're telling us this in the beginning. This was given, so I just wrote it down mathematical. Now let's call that equation 1. Okay, now there's another thing that is also given on this thing. Okay, on this diagram they say that L is on the is a point on this KL. I'm not sure if you can see that, but this is a point on that one. And remember, we calculated that equation of this line where in question 3.3 we already calculated the equation of that line. So we're going to call that y is equal to x plus 3, and let's call that equation number 2. So the reason for that is I'm going to start substituting. I'm going to do simultaneous equations, because if I do that, I feel and I see further on that I'm going to get a value of x. That means I'm going to get a value of y. So it's going to be a lot of work now. I'm going to substitute this in there. Okay, so let's do that. So everywhere I see y, I'm going to substitute this. So let's leave that as it is. So it's going to be x plus 3 squared plus open bracket. Instead of y, I'm going to substitute x plus 3. So let's do that, x plus 3. Here's a plus symbol, so there's a plus symbol. Here's 5, and everything is squared, equal to 13. Okay. So let's expand all of this stuff. So it's going to be x squared plus 6x plus 9 plus x squared plus 16x plus 64 is equal to 13. Okay, I'm just getting rid of the brackets. So if I add up like terms, this and this is going to be 2x squared, and all my x's, if I add that, that's going to be plus 22. Whoa, why am I writing like that? Plus 22x. Sorry about that, guys. And 9 plus 64 is going to give us plus 60, equal to 0. 9 plus 64, 9 plus 64, and I took this to the left side, so this is what I have. Okay, now I'm just going to simplify this further onwards. Okay, so it's going to be divide by 2, so I get x squared. Divide that by 2, I get 11x. Divide that by 2, I get 30 equal to 0. So now this is a quadratic equation. I can factorize this. So it's going to be 2 brackets equal to 0. So 1 is going to be x. That 1 is also going to be x. This is going to be plus 5. And this is going to be plus 6. Add this, we get that. Multiply, we get that. So that means 1. That means one x value is going to be negative 5. And the other x value is going to be negative 6. Okay, so let me say all there. Okay, now I have the x values. I still need the y values. So I'm going to substitute this into this formula here, or this equation, to get my y. So let's substitute 5 in there. We're going to get y is equal to negative 2. And then the other y value, we're going to get negative 3. So that means the possible coordinates, because that's what they ask us, the possible coordinates is going to be negative 5 and negative 2. Or it can be, the other option or other one can be, the x value is negative 6 and negative 3. And that's your final answer. So that's a mouthful. But the most important thing was you kick off with this. Okay, so let's see if there's any questions here. Okay, Paulvin, are you going to do trigonometry today, tomorrow? The goal is, guys, I wish I could show you my screen now, because my phone is charging, and it showed that it's charging here, but it showed my battery is on 1%. The goal is to do, no, trigonometry. I don't think I will be able to fit in trigonometry, but I have it here, I got it here, it's in front of me, okay? That's the goal. And I'm not sure, and here's analytical geometry as well. Can you do double angle identities? In the trigonometry question, there is double compound angles, yes. Any questions that you have for this one? We still have 20 minutes left, but I doubt that we're going to be able to finish it, because something is not right. Because it showed that my cell phone is charging. Okay, so remember the coordinates of, so I do apologize in advance if this live ends just like that, then it means it's battery power. Okay, so remember that possible coordinates of this one is negative 5 and negative 2. So I'm just going to say negative 5 because we might use it, so I'm going to write it on here. Or it can be negative 6 and negative 3. Negative 6 and negative 3. Okay, so it can be that or it can be that. I'm not saying which one it is, because later on we will maybe use it. Okay, so let's go on to the next one, which is 3.5.2, where they ask us determine the coordinates of L if the so we're looking, no, wait, determine the coordinates of L, right, if it is given that KLMN is a parallelogram. Oh my shit, here we go.